Hello and welcome back to the next lesson. Today we're going to start the process of site selection for when we go out in the field. We want to know where we can sample. So the first thing that is going to really determine where we can sample is slope. Remember, slopes over 30 degrees are avalanche terrain, so we will absolutely not be sampling there. We're going to start by changing the symbology so we have a better idea of where we want to sample. So I'm going to right click on slope, go to properties, and it will bring up the properties in Symbology. I'm going to change to single band pseudo color. My interpolation method, I want to use discrete, and I want to use the mode of equal interval. This now creates different classes where it categorizes, and I really only want 4 for this purpose. When we dig pits, it's easiest to dig on areas that are less than 10 degrees. So I'm going to right click and choose 10 degrees and change my color to something that I like, such as green. Green means go. That's a good place to go. And you can change the label here. And I'm going to call this preferred sampling. I think I spelled preferred wrong. Preferred. Okay, the next place we want to do is 15 degrees or below. So 15 degrees or below is sort of not quite preferred, but we can still sample in there. So possible sampling. And I'm going to change this to a nice blue or something like that. Okay. Next, we are going to have 30 degrees, and we want to make sure that 15 to 30 degrees is not in our sampling zone. So I'm going to call this no sampling. And lastly, 30 to 90, 90 being the maximum. This is avalanche terrain, and we will definitely not be going there. Okay. So now that I've completed that, I'm going to change this one to bright red. Red means no go. We can go ahead and press OK and take a look at where we've got. So we can see our green and blue zones are where we want to be sampling. Kind of gives us an idea here. And our red zones definitely will not be wanting to sample in there. So that is with slope. The next thing we are going to do is repeat that with aspect. So you might recall aspect. I just used the turbo color scheme. So you can go ahead and repeat the same thing where you do discrete 8 classes on equal interval. And I've changed the labels like that. That's how it will show up in a legend if you make a map in map layout. Okay. The next thing that we are going to do is bring in our fractional vegetation data set. So in your working directory, East River Basin, fractional vegetation at 50 meters. There is not a 3-meter version of this, so I'm just going to be using a 50 meter. I know it is coarser, but this will work for the teaching purposes. So the first thing I'm going to do is take a look here. It ranges from 0 to 64, so 64%. Seems to be the max. I will note that this is made by a machine learning algorithm, and so it's not totally perfect, but it's as good as we can do here, because theoretically you would have 100% tree cover. Sort of density though. Okay, so I'm going to change this to single band pseudo color and go to greens, and now you've got a good sense of what it looks like. This covers a much larger extent, so I'm going to zoom to layer. The next thing I want to do is create a mask of essentially where trees exist and where they don't. So this is going to be done in raster calculator again. And I have my raster calculator expression here, and I'm going to do if my fractional vegetation data set is greater than 20, 20 is percentage, then I want to give it a 1 for forest, and if not, I want to give it a 0 for no forest. I'm going to go ahead and save this as my fveg binary mask, and I'm going to go ahead and run it. Okay, so now you can see that anywhere that we have white, we have trees. Anywhere we have black, we have no trees. You can change the the colors as you see fit. Now you can see where we have trees and where we do not. Okay, next thing we're going to do is bring in our weather station data. So we've got these weather stations set up on Snodgrass Mountain. And when we choose our sampling sites, we want to make sure we are not sampling near those weather stations for risk of disturbing them. So I'm going to go ahead and drag in this WX stations shapefile. And those just populated, very small. So I'm going to zoom to the layer where they are. You can see there are these little dots. I'm going to make those bigger by going to properties. I'm going to choose a nice diamond and maybe bump the size up a little bit. And now we can see those nicely here. Okay, now that we have these here, I want to make a buffer around them because remember, we don't want to be digging near them. So I'm going to type buffer in my processing toolbox, and under vector geometry, I'm going to do buffer, double click, make sure your weather stations is the one that's added. Make sure you were in meters and your distance should be 10 meters. So that means it's going to make a buffer around those weather stations that is 10 meters. Go ahead and run it, and you will see the buffer that results. I'm going to turn off the weather stations, and I'm going to change the symbology here. I like this hashed black one. And now you can see we've got a no dig zone right there. So that is super helpful. I'm going to bring in the study domain, and this will populate right here. I'm going to change the symbology. The red outline shows up well. And so this is where we can access from the road within reasonable distance when we go out into the field. Okay, we have everything we need to begin to determine where we want to dig our sampling pits. However, they're all on different layers. So in the next lesson, I will show you how we are going to go about selecting these areas in a methodical manner. Thank you so much. See you in the next video.